use this tutorial if you're having trouble understanding how to take a standard form equation and turn it into a slope-intercept form equation. Solutions will be shown here. Let's say you're given on number 1, 2x minus 3y equals 6. The goal is to get y by itself, so we'll start by subtracting 2x from both sides. On the left, the 2x minus 2x cancels it out, and you have negative 3y equals negative 2x plus 6. And now, to further isolate the y, divide everything by negative 3. On the left, the negative 3's cancel, and you have achieved the goal of getting y by itself. Y equals negative 2 over negative 3 is positive 2/3 x. And then you have 6 divided by negative 3, which gives negative 2. And that's your answer. The reason we do this is to get the form y equals mx plus b. And so this is in that form now, and we can bracket it. Number 2, 7x plus 2y equals negative 12. Subtract 7x from both sides. You're left with 2y on the left equals negative 7x minus 12. And then divide each term by 2 in order to get y by itself. The 2's cancel out on the left, and you have, again, achieved y equals, you have negative 7 over 2 x. Negative 12 divided by 2 is negative 6. And so you have y equals negative 7/2 x minus 6. That's your answer there. Again, it's in slope-intercept form. Numbers 3 and 4 are not in slope-intercept form. They're given in point-slope formula, in point-slope form. That form is y minus y1 equals mx minus x1. So we have to finish the job. First thing, following order of operations, is to distribute the slope, which is 2/3, through this parentheses here. So we will rewrite y plus 2 equals 2/3 times x is 2/3 x. And now 2/3 times 4 is the same as 2/3 times 4 over 1. So you have 2 times 4, which is 8 over 3. So plus 8/3. And now we subtract 2 from both sides. Okay, the 2's cancel there, and you have y equals 2/3 x. And we have to deal with the fact that we have a whole number and then a fraction. And so we have to turn negative 2 into a fraction whose denominator is 3. So we multiply negative 2 times 3 over 3. And what that gives us is, we'll just put in here plus 8 over 3. And now negative 2 times 3 is negative 6 over 3. Negative 6 over 3. The benefit now is that we have common denominators. We can subtract these numerators. So I'm going to subtract 6 from 8 on the next line. So I have y equals 2/3 x, and then 8 minus 6 over 3. 8 minus 6 is 4 over 3. And that's positive. So plus 4. Sorry, not 4. 8 minus 6 is 2. Plus 2/3. So the final slope-intercept form of the equation is y equals 2/3 x plus 2/3. We check to make sure the slopes match. Yep. And the y-intercept in this case is also 2/3, just by coincidence. Number 4, your slope is -1. Use this negative symbol out here by itself. That equals -1. So the rise is -1 and the run is 1. So m, just so you understand, m equals -1 over 1. Or in this case, it's just a minus sign. Because this is in point slope form, y minus y1 equals m x minus x1. Okay, so what I'll do now is distribute the negative symbol. It's really multiplying each term by -1. So rewrite y plus 5 equals -x, and then -1 times -2 is +2 plus 2. To get y by itself, subtract 5 from both sides, and you get y equals -x, and then 2 minus 5 is -3. So we have y equals -x minus 3. Numbers 5 and 6, we're given the slope and we're given a point. So we should use the point slope formula to solve. Again, that point slope formula, y minus y1 equals m, open parenthesis, x minus x1, close parentheses. So we're going to plug in our numbers. Here, 3 is x1, and -4 is y1. Down here, I'll write y minus y1, which I'll put in parentheses because it's negative, y minus -4 equals m, which is -7 over 3, -7 over 3, open paren, x minus x1, which is 3, x minus 3. And now we have the same problem we had before. We have the problem in point slope formula. We need to convert it into slope intercept formula. So back here, a negative and a negative make a positive. So I have y plus 4 equals, okay, I'm now going to distribute -7/3 through the parentheses. -7/3 x plus, and now I have -7 times negative 3. So I get 21 over 3, because it's negative 7/3 times negative 3. (21 over 3) can be reduced, and we'll do that now. Y plus 4 equals negative 7/3 x plus 7. And now I'll subtract 4 to get y by itself. And I have y equal to negative 7/3 x plus 3. Next problem, passing through 1 comma negative 4, this will be my x1, and this will be my y1. And here's the m. So just plug into the formula. Y minus, open paren, negative 4, close paren, equals negative 3 for m, open paren, x minus 1, close paren. Now I have to get that negative negative to go away, and I'll distribute the negative 3 into the parentheses. So I have y plus 4 equals negative 3x plus 3. To get y by itself, I'll subtract 4 from both sides. I have y equals negative 3x. 3 minus 4 is negative 1. Okay. I'm just checking my answer in my head. I want to make sure I did that correctly. Okay. Number 7 and 8 require us to find the slope, and then we can use point slope formula. So first we have to find the slope. It'll be useful to remember the slope formula. So slope m equals y2 minus y1 over x2 minus x1. We have to plug in values into this formula, so we should label our coordinate points correctly. x1, y1, x2, y2. You must label your points or you will get them confused. So now we find slope m equals y2, negative 5, minus y1, so negative 5 minus 3, over x2, 0, minus x1, so 0 minus 2. And we'll extend this equal sign right here and keep going. Negative 5 minus 3 is negative 8. And fraction bar. 0 minus 2 is negative 2. So now I have negative 8 over negative 2, and that is equal to positive 4. So the slope is 4. Now I can use the point slope formula we just need to use one pair of points here. You could use either pair of points. Typically, I just go with the first pair for no other reason than the point slope formula says to use x1 and y1. But just so you know, all you need is the slope and one coordinate pair. So you could use either coordinate pairs. You can try it for yourself. You'll get the same answer, regardless of which coordinate pair you use. I'll just use the 2, 3 since I labeled them x1, y1, and that's what's in the formula here to avoid confusion. Okay, so now I'm going to plug into this formula using these 2 points here and that slope right there. So I have y minus y1, which is 3, y minus 3 equals m, which is 4, open parentheses, x minus x1, which is 2, x minus 2, close parentheses. And now I will multiply the 4 through the parentheses. So we'll rewrite y minus 3 equals 4x minus 8. And to get y by itself, I will add 3 to both sides. I now have y equals 4x minus 8. Negative 8 plus 3 is minus 5. So y equals 4x minus 5. And we can box that. Next problem. Passing through negative 3, 0 and 0, negative 1. This is going to be especially important here that we label appropriately x1, y1. And ran out of ink. x2, y2. Okay, so we start by finding the slope. M equals y2, negative 1, minus y1, which is 0. Negative 1 minus 0. Over x2, 0, minus x1. So watch carefully. Minus, open parentheses, negative 3, close parentheses. That way you don't lose track of the minus signs. So let's extend the equal sign here. So m is equal to, up on top I have negative 1 minus 0, which is just negative 1, over 0 minus 3 is positive 3. So I have negative 1/3. So I'll just put another equal sign and make this negative 1/3 is the slope. Now we can use the point slope form to plug in our values. Y minus y1, which is 0, equals m, negative 1/3, open parentheses, x minus x1. So x minus, open parentheses, negative 3, close parentheses, and then close the bigger parentheses right there. Okay, we don't need to worry about that 0. We can just say y equals. And now we will distribute negative 1/3 through the parentheses, taking care of these two, this double negative right here along the way. I have negative 1/3 x, and now I have negative 1/3 times positive 3, which gives me plus 3/3 thirds. Okay, those cancel down to 1, and we'll show that here. Y equals negative 1/3 x plus 1. Put a box around it. Number 9, sketch the graph of each linear inequality. Well, first we have to solve for y. Right now, this is in standard form. We'll rewrite it down here. 9x plus 4y greater than or equal to 16. Solve for y. Negative 9x minus 9x on both sides. So we'll subtract 9x from both sides. Now we have 4y greater than or equal to negative 9x plus 16. And to get y by itself, we will divide everything by 4. The 4's cancel on the left. We did not divide by a negative, so nothing changes. We have y greater than or equal to negative 9/4 x plus 16 divided by 4 is 4, so plus 4. We can now graph this. Remember, we have our equation in slope-intercept form, so it's applied to this particular linear inequality. It's y is greater than or equal to mx plus b. So we know what the slope is, and we know what the y-intercept is. We know this is a greater than or equal to symbol, so don't forget, greater than or equal to means, and we have a negative slope, so it means I'm going to have a solid downward sloping line. If I draw dots, they'll be filled in, and I'm going to shade below the line or above the line? Above the line. Okay, so there's your model. But let's get going. We start at the y-intercept, and we'll put a dot there, filled in dot. And now we're going to use our slope, thinking rise over run. In this case, we're going to fall. Go down 9, and then to the right 4. So starting with your pen or pencil on y equals 4. On the y-axis, go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then go to the right 4. 1, 2, 3, 4. Okay, put a little dot there. And now we can connect the 2 points like this. Okay, and we're going to shade above that line. Okay, so just shade above that line. And that's that. We'll do the next one. X minus 2y less than negative 2. So we'll start by rewriting it. X minus 2y less than negative 2. I'm looking ahead in the problem. I can already tell I'm going to have to divide by a negative, but we'll get there. First, I'm just going to get y by itself. First, I'll subtract x from both sides, just like that. I'll write negative 2y less than negative x minus 2. Now I will divide by a negative and divide everything by negative 2. and that cancels the two negative 2's on the left, leaving y by itself. And I must flip the sign now. So now y is greater than. Now I have negative x divided by negative 2. Remember, negative really means negative 1. So I have negative 1x divided by negative 2. That leaves 1/2, 1 over 2. If you miss that, pause, go back 10 or 20 seconds and watch that again. X, and now negative 2 over negative 2 is plus 1. Okay, negative divided by a negative. Okay, so now this is again in that slope-intercept inequality form. I'm dealing with a greater than symbol, so what am I going to do? I will have, and I've got a positive slope, so I'm going to have an upward sloping dashed line. If I have anything I bubble in or circle in, I'll use an open circle, and because it's greater than, I'll be shading above the line. Okay, so going into the problem, you already know what you're going to do. We'll start at the y-intercept, which is 1, and I'll put an open circle there. It just means that that is the y-intercept, but according to this inequality, that particular point is not contained within the solution set. That's what that open circle means. Now, with a slope of 1/2, my rise is 1 and my run is 2. So it will be up 1 over 2. So starting at 1, I go up 1 and then to the right 2. 1, 2. Put a little open circle. Right? You can do it again. Up 1, starting from that point you just put an open circle. Up 1 over 2. Put another open circle. You can see a straight line start to form. So connect it with a dot. Connect all the dots with a dotted line. Okay, just like that. Now shade above that line. Okay. Now you've done with that one. It's not coming in very dark on your screen. This one, it's a little bit darker here. Okay. Moving on to number 11, we're going to solve each equation by factoring. Then it says make sure you factor each equation, then take those factors, set them equal to 0, and solve them. All right, we'll see what that means in a minute. Remember, with quadratic equations that are already set equal to 0 and have a leading coefficient of 1, like this one does, what you do is you need to find two numbers that add to be the middle term, and those same two numbers need to multiply to be the last term. So we need two numbers that add to be -2 and multiply to be -24. I can start a little factor tree here, -24, and just think about the numbers that I could use to get that. I could do -24 and +1, but those don't add to -2, so that's not it. I could do -12 and +2. No, those add to -10, so not -2. That can't be it. How about -6 and +4? Okay, those multiply to be -24 and they add to be -2. So my factors are -6 and +4. Write that twice here. Now you're going to take this standard form equation of the quadratic, ax squared plus bx plus c equals 0, and we're going to write it in the factored form. Open paren, close paren, open paren, close paren, still equals 0. And inside, we will write in and in, and we'll put our factors. In minus 6, in plus 4, right? And they're equal to 0. Make sure that plus symbol is clear. So we set each of the factors equal to 0. So I'll have in minus 6 equal to 0 and in plus 4 equal to 0. Now I solve for, in this case, in on both of these little equations. Just add 6 to both sides here, and I have in equals +6. And here I have n plus 4 equals 0, so I'll subtract 4 from both sides. And I have n equals -4. So my solutions are -4 and 6. You can write them like that. As long as you show that that's how you got your work done. Number 12. Let's find two numbers that add to equal the middle term, which is 2. Okay. And those same two numbers need to multiply to equal the last term, which is -8. So let's figure that out. -8, break it down. I could do -4 and +2. -4 and +2 equals -8 when you multiply, but when you add, you get -2. So why don't I flip those? I have +4 and -2. Now I still get -8 when I multiply, but when I add, I get 4 minus 2 is 2. So those are the factors, 4 and -2. 4 and -2. Take your standard form quadratic and write it in factored form. In this case, we'll be using a's. So a plus 4 and a minus 2. And then we will set those factors individually equal to 0 and solve them. So a plus 4 equals 0, subtract 4 from both sides. I have a equals -4. Now I have a minus 2 equals 0, so I will add 2 to both sides. Now I have a equals +2. So my solution set is -4 and 2. And remember, guys, these are the places where these graphs will cross the x-axis. These are called the solutions. These are called the factors. The factors are in parentheses, okay? And they have to be set equal to 0 to solve for the solutions, or the zeros. In other words, y is 0 here, y is 0 here, y is 0 here, and y is 0 here. When x is -4, y is 0. When x is 6, y is 0. When x is -4, y is 0. When x is 2, y is 0. Okay, we're just going to do this again 2 more times. Standard form quadratic, leading coefficient of 1. There's nothing to do except start working. I need two numbers that add to equal the middle term, which is positive 5. And those same two numbers need to multiply to equal the last term, which is negative 6. So we'll take negative 6 and break it down. I've got negative 6 and positive 1. Okay, that equals negative 6, but when I add them together, I get negative 5, and I want positive 5. So what if I flip those? Positive 6 and negative 1. Now, 6 minus 1 is 5. 6 times negative 1 is negative 6. So those are the factors, 6 and negative 1. 6 and negative 1. Okay, take your standard form quadratic equation and rewrite it in a factored form quadratic equation. I think I dropped the equals 0 up here just to be correct. Okay, and here we're going to use n plus 6, and then n minus 1. A couple people have asked, does the order matter? No. Remember, this is just the form called factored form. You could always recombine these into that. Okay. If you used the FOIL method, you could recombine those to get this original equation. First, n squared, outer, negative 1n, inner, plus 6n. You combine those two terms, you get negative 1n plus 6n is positive 5n. And then last, 6 times negative 1 is minus 6. So there's your equation right there. Okay, continuing on, set these factors equal to 0. And solve for n. So I've got n plus 6 equals 0. I'll subtract 6 from both sides. I get n equals negative 6. And I've got n minus 1 equals 0. Add 1 to both sides. And I get n equals 1. So my solution set is negative 6, comma, 1. Just like that. Finally, r squared plus 8r plus 12 equals 0. It's a standard form quadratic with a leading coefficient of 1. We need to find two numbers that add to be the middle term, which is positive 8, and multiply to be the last term, which is positive 12. So I take 12 and I break it down. I could do 1 times 12, but that equals 13. I could do 2 times 6. 2 times 6 is 12. 2 plus 6 is 8. There's our factors, 2 and 6. I don't know about you, but it's always like a sunnier, happier problem when there's no negatives. See? These are all positives. Get it? It's like a joke. So now we'll turn the standard form quadratic into a factored form quadratic. You have r, and we'll put plus 2 and plus 6. Take those factors, set them equal to 0 individually. And then solve. R plus 2 equals 0. Subtract 2 from both sides. You get r equals negative 2. R plus 6 equals 0. Subtract 6 from both sides. Get r equals negative 6. So your solution set is negative 6, comma, negative 2. On all of these, I just ordered them least to greatest, just by like it's good form. Okay, that's the whole assignment.